All right, this is going to be a video walkthrough of how to do that worksheet 5 heating curves. And you've got the information for the question. So the question gives us 72.3 grams of ice. We have, it's starting at negative 15 degrees Celsius, and this will end at 145 degrees Celsius. So in class, you went ahead and you labeled which formulas you're going to use. I'll label them quickly right now for us. All right, so now I've got the formulas written down that I'm going to need for this problem. So the first one is A, calculate the energy required to heat the ice to its melting point. Well, I'm going to be looking at this portion of the graph, and the formula I'm going to use is Q is equal to M, my mass, times the specific heat of water, times delta T. So the next thing to do is to pull out those numbers. Because this question is starting with ice, we've got 72.3 grams of ice. It's going to be taken all the way through the problem. In fact, I'll end up with 72.3 grams of steam at the end. My mass is always, through the whole problem, my mass is going to be 72.3. So Q is what I'm going to calculate for. My mass is equal to 72.3 grams. My C is going to be the specific heat of ice, which is 2.10 joules per gram per degree Celsius. And that's all I need for this problem except for my change in temperature. My temperature is going from negative 15 to 0. This is water and it melts at 0. So it's going to be a change of 15 degrees Celsius. So now I'm going to substitute my numbers in. Oops, I think I reversed my numbers there. That in your table is 2.01. Times my delta T, which was 15 degrees Celsius. When I put that in the calculator and multiply those numbers together, I got now let's make sure my units make sense. Gram is canceling off, gram is canceling off, Celsius is canceling off, Celsius is canceling off. I'm left with joule, and that's what I need for my answer. Now, let's look at significant figures. These are the numbers that are going to give me my significant figures. So whenever I have numbers that originated from these, that's how I'm going to count my significant figures. So I've got 2 significant figures because of this number right here. And so I'm going to need 2 significant figures in my answer. Now I'm ready to do the next part of the question. Calculate the energy required to melt the ice. Well, my formula is going to be, I'm on this part of the graph here. So my formula is going to be Q is equal to the mass times the heat of fusion. My mass is going to be the same, 72.3 grams. The heat of fusion is given to me up here in my problem. And I look and I find that that's 6.01 kilojoules per gram. All right, now I'm ready to put this in my problem. Cross off my units that are the same. And my Q will equal the 72.3 times 6.01 And that'll give me, I'm going to do my sig figs here since I'm running out of space. It'll give you with 3 sig figs, it's going to give you 435 kilojoules. So 435 kilojoules, I notice that I've got joules here. I want to make sure that all my answers together, I'm going to need to add these all together. So I want to make sure that my units all match. When I do a little dimensional analysis, that will give me 435,000 joules. So I've just converted kilojoules to joules. Okay, and I'm on to the next one. Calculate the energy required to heat the water to its boiling point. So now I'm going to be looking at this portion of the line. I'm starting at 0 and I'm ending at 100 because this is water. So the formula I'm going to need is Q equals MC delta T. My mass is the same as it's been all along. The C for water, because this is the water portion, we already know is 4.18 joules per gram per degree Celsius. My delta T, it's starting at 0. It's ending at 100, so my delta T is going to be, 100 degrees Celsius. Now I'm going to plug my numbers in. Make sure my units are canceling off. Grams, grams, Celsius, Celsius. I'm going to be left with joules for my answer. And when I put that in the calculator, I got
May I have your attention, please?
All right, so now I'm going to look at how many significant figures I need. Remember, I can only use the numbers that were given to me in the problem for my significant figures. This was the number that was given to me in my problem, 72.3. The 100 is what I wrote on my graph as my ending point. That's not going to give me a significant figure. So when I'm figuring my figures, go figure, I'm going to need 3 significant figures in my answer. So that's going to be 30200, and my unit is going to be joules. Now I'm ready for the next part. Calculate the energy required to vaporize the water. So I'm going to be in this portion of my graph, and I'm going to use the formula that's right there. Q equals the mass of the water times the H of vaporization. My mass stays the same. 72.3. I have to go up here to find the heat of vaporization. That's going to be 40.7 kilojoules per gram. Plug it in my formula. Cross off my units. I'm left with kilojoule. And when you multiply these two together, you get Looking at my problem, this is the number that came from the question. So I'm going to have 3 significant figures, which means this will equal now my answer is in kilojoules, so I really should convert that to joules. So I've got a little room here, so I'll go ahead and do that. Kilojoule on the bottom. If you look on your conversion table, 1 kilojoule will be 10 to the 3rd joules. My units are canceling off. I'm going to be left with joules, and that's going to give me 2940000, and that'll be joules. So that goes in the box up here. Okay, on to the next one. So now it says calculate the energy required to heat the steam to 145 degrees Celsius. So now I'm in this portion of the line. I'm starting at 100 degrees and I'm ending at 145. That's where I needed to end. So my delta T is going to be the difference from 100 to 145. My delta T will equal 45 degrees Celsius. So my formula is going to be Q equals mc delta T. My mass is the same. The C I need to get for steam. I go up here, there's steam. So it's 2.02 joules per gram per degree Celsius. And then my delta T, I'm going from 100 degrees, where I left off with the other problem, to 145. So my delta T is going to be 45 degrees Celsius. Put this all in the question, or in the formula. Make sure my units are canceling off. I've got gram, gram, Celsius, Celsius. The only thing I'm left with is joules. I put that in the calculator, and I get an answer of this was kilojoules. Didn't copy that down right. No, it wasn't kilojoules. Okay, now I'm going to go ahead and put that in my calculator. And that will give me for significant figures, I'm looking and I've got 2 significant figures. This was the number that I got. I've got 3 significant figures in this one. I've got 2 significant figures in this one. Remember, this temperature came from what I was given in the table. My measurement was to the ones place. So I'm going to say that that's 2 significant figures. And that will give me 600 or 6,600 joules. Now the last step is to add all these numbers together. So I'm going to add A through E, because this is going to be the total amount of energy that it takes to go from this point through that to here, to here, to here, to here. So the total amount of energy for this whole process is, when you add these all together, 3,414,000 joules. And that's your final answer.